Oh, hello, I didn't see you there. Oh, well, in this tutorial we're going to teach you how to solve a rational function and at the same time how to graph it. My team and I will do our best to explain it to you so you have no problems with your math class. Let's begin, shall we?
Rational function, we will use this one as an example, which is 3x squared plus 4x minus 15 over x squared plus 2x minus 3. First, we put the parentheses, and it is 3x minus 5 times x plus 3 over the parentheses x plus 3 times x minus 1. Then we get the asymptotes. But first we cancel these ones, and to get the vertical asymptote we had to have the denominator equals 0, so it's 1. And to get the horizontal asymptote we gotta divide the numerator over the denominator, which is 3.
Now, in the next section, we're going to explain how to get the x-intercept, the y-intercept, and the discontinuity point, better known as whole.
To find the x-intercept, we have to equal the numerator to 0, and we have, as a result, 5 over 3. And to find the y-intercept, we have to take the last two terms on a rational function, and our result will be 5. So we put it like 5 over 3 and 0 and 0, 5. Here we cancel the term x plus 3, so we can assume that the whole is in the point x equal to minus 3. So we substitute this value on the rational function we have here. Now substitute this value in the factorized form, and we have 3 times minus 3 minus 5 over minus 3 minus 1. So we have minus 9 minus 5 over minus 4. That is minus 14 over minus 4 equal 7 over 2. So we have here the y point on the graph, so we have the whole in minus 3, 7 over 2.
In this next part, we're going to explain the end behaviors of the rational
In
function.
end behaviors, we need the test values. But where do we get those values? Well, first of all, we need the asymptote. And in here we need a lower value. It will be 0.9. And here we need a higher value. It will be 1.1. Now we have to substitute in our function. And this will allow us to see the sign. And it will be negative over negative, it will be positive. And now we know that this part of the graph will be positive. For the other side, we're going to do the same. So we substitute. And here we have negative over positive, and it will be negative. So this part of the function will be negative.
In the next part, we're going to explain now how to graph it. So, first off, we're going to start by putting the asymptotes. The first one is the vertical asymptote, and it's x equal to 1. So we're going to put it kind of like this. And the second one, which is the horizontal asymptote, which is equal to 3, y equal to 3. So we're going to put it like Okay, Next, we're going to do the intercept, which is going to be x-intercept, the first one, and it's equal to 5/3, 0. So it's going to be around here. And the second intercept, the y-intercept, which is 0, 5, which is going to be over here. Now, we're going to plot the whole, or the discontinuity point, which is equal -3, 7 halves, which is going to be around here, right? Yes. Let's remember that this is an open point, okay? So now we have that the A behaviors, they're both negative. So now that we have plotted the intercepts, the whole, and the asymptotes, we're going to proceed to actually graph it. So now that we have the M behaviors, we know that the first one is going to be positive and the other one is going to be negative. So if it is positive, the first one will look something similar to this. And then, like this. Right? It's positive, and it's going up. And the second line, we know it's negative, so it's going to be looking something like this. And then like, and that's how you graph rational.
We put from -infinite to our whole, which is -3, union -3 to our asymptote, which is 1, union 1 to infinite.
First, we know that we go from -infinite and we first stop in 3 union 3, 7/2, and finally we go from 7/2 to infinite.
Thank you for watching. See you next time.
Bye bye!